Hi teacher, my name is Kwok Ming Ming and my group member is Xiu Jin Xiong and Liu Yao Xiang. Today I want to discuss about my mini project. The topic of our mini project is vending machine.
Good morning everyone. My name is Yuraj and today I have the privilege of introducing our mini project on the FSM based vending machine. Vending machine is an automatic machine which is used to dispense various products such as snacks, beverages and etc. A vending machine dispenses small items automatically when you insert specified amount of money. Vending machines have been in existence since 1880s. The first commercial operated machine was introduced in London and England used for selling postcards. The vending machine brings convenience to people and are more accessible than the conventional purchasing method. Nowadays, vending machine can be found everywhere like in a shopping mall selling beverages and in school selling snacks and food. In this project, we will design a simple FSM based vending machine using milli machine and shift register concept which is parallel in serial out. We will use 4D flip-flop to design a fresh milk vending machine. The secure design will implement the basic function of a vending machine. The price for a tin of fresh milk is Rm 3 ringgit and the machine will only accept Rm 1 ringgit and Rm 2 ringgit. The output of the machine will be 1 high and it will dispense a tin of fresh milk when the credit is equal to Rm 3 ringgit. If the user attempts to select an item without having or not enough amount of coin, the machine will be low and it will not respond until a valid action is performed. This machine does not provide any changes if the consumer insert more money. User must insert exact money of coins in order for a machine to function. This machine is milli machine, which is the output depends on the input. The final state machine is set of all possible states and control sensation from state for state. In, in response to external input, it is a mathematical tool used to describe process involving input and output.
And now we come to problem statement of the project. As physical stores are not available at all circumstances, we can set up vending machine at any place to provide convenience. And besides, vending machine have mobility, they are portable and can deliver service at all time. Vending machine is a self-service device. It helps to eliminate the need of human resource, and customer can easily access the product at any places. And the objective of this project is to perform and improve teamwork among group members. And secondly, this project to learn how to use the strength and weakness among group members. And third, this project is to provide certain degree of planning and budget management. And moreover, this project is to implement the knowledge acquired theoretically into hardware. And lastly, the objective of the project is to enhance computer-aided design skill. And the scope of work of this project is the aim of this project is to design a fresh milk vending machine to help students in university. It is a single select fresh milk machine with final select machine batch, which is Mary machine. The Mary machine is a final step transducer that generates an output based on its state and input. This means that the user must insert amount of money type of 1 and 2 ringgit to buy a tin of fresh milk. The output of the machine will be high and it will dispense a tin of fresh milk when the credit is equal to 3 ringgit. If the user attempts to select an item without having or not enough amount of money, the machine will be low and it will be not respond until a valid action is performed. Thank you, teacher.
The state diagram for the fresh milk vending machine. To obtain the fresh milk, we'll need a total of RM3. This vending machine will only accept RM1 and RM2. There are two inputs for this vending machine, which is D and N, D representing RM2 and N representing RM1. In this state diagram, we can see that the output will only be one when any either of the states goes to state 3, sorry. It will go to state 3. If it goes to the other state, the output will only be 0 to represent that it haven't reached the money required to get the fresh milk. This is the state table. There's the present state, the input D and N, next state, and output. There are a total of 4 states of input, which is 0, 0, 0, 1, 1, 0, and 1, 1. When the present state is RM0, if you insert 0, 0, which is RM0, you get an output of 0. If you insert 1, 1, which is the total of RM3, you'll get the next state will be RM3 and the output will be 1 since you have enough money. If it's RM1, when you insert 1, 0, it will become RM3 and the output will be 1. But if you insert 1, 1, which is RM3, RM1 plus RM3 equals to RM4, so it's already exceeding the amount needed, so we'll ignore this state. For RM2, will be the same. 1, 0 and 1, 1 have already exceeded RM3, so we'll also ignore it. 0, 1, which is RM1 plus RM2 equals to RM3, and we'll have output 1 output. For RM3, since it's already enough, so we'll just ignore anyone with 1, and then only goes with 0, 0, RM3, output equals to 1. This is the transition table. The only thing that we change is the RM0 equals to 0, 0, 0, 1, RM1 will equals to 0, 0, 1, 0, RM2 will equals to 0, 1, 0, 0, RM3 will equals to 1, 0, 0, 0. This is the K-map to obtain the Boolean expression and to draw the circuit diagram. So in this K-map, we will get A plus equals to D bar N bar A plus D bar N B plus D N bar C plus D N D O. B plus equals to D bar N bar B plus D bar N C plus D N bar D O. C plus equals to D bar N bar C plus D bar N D O. DO plus equals to D bar N bar DO. The output, since we're only attached to A, so when A is 1, it will become 1. If A is 0, it will be 0. This is the state diagram we have obtained from the Boolean expression in the K-map just now. Essentially, we're going to use PISO, which means that we have every single for inputs which represents the present state. Every single one of them will be going into the every 4 flip-flops here, and the flip-flop the output will all be single. We have 5 outputs, which is A1, B1, C1, DO1, and open. The open will represent whether it is enough to buy the fresh milk. So we're going to be using 4 diff flip-flops, and for A1 we're going to have 4 AND gates, B1 we have 3, C1 we have 2, and D1 we're going to have 1, as we gotten from the expression in the K-map. So this is the waveform of it. As you can see, the input DN will have 0, 0, 0, 1, 1, 0, and 1, 1, all representing different state inputs. The present we have 0, 0, 0, 1, 0, 0, 1, 0, 0, 1, 0, 0, and 1, 0, 0, 0. So for the next state, like for example, 0, 0, 0, 1, when the DN is equals to 0, 0 equals to 0, 0 ringgit inserted, so it will remain the same 0, 0, 0, 0, 1. If you have an input 1, 0, which equals to 2 ringgit, since D is RM2, so its next state will be 0, 1, 0, 0. Output will also still be 0 since it has not achieved 3 ringgit. Only when for 0, 0, 0, 1, which is 0 ringgit, when you insert 1, 1, which is 3 ringgit, you'll have 1, 0, 0, 0 equals to 3 ringgit, and the output will be 1. For 0, 0, 1, 0, when the input is 1, 1, since it will be exceeding RM3, so will be ignored, and it will become 0, 0. It will return to 0, 0, 0, 0, and the output will be 0. And 0, 0, 1, 0 equals to 1 ringgit, and if you insert 1, 0 plus 2 ringgit, it will equals to 1, 0, 0, 0, so it will be 3 ringgit, and the output will become 1. For 0, 1, 0, 0, we will ignore 1, 0, and 1, 1, so After inserting this both inputs in here, we have 0, 0, 0, 0, and meaning it's ignored. And when inputting 0, 1, which is 1 ringgit, it will become 1, 0, 0, 0. For 1, 0, 0, 0, since it's already 3 ringgit, so we only accept 0, 0, which is 0 ringgit, and you have 1, 0, 0, 0, and 1 ringgit. Others have already exceeded 3 ringgit, so it will be ignored. This will be all for the circuit and waveforms. Thank you.
In this mini project, we achieved to form and improve teamwork among group members. Everyone was highly collaborative. Team meetings were always friendly and there was no stage team issues discussed as being problematic. Team members always focus on the project and how the process of development could be improved by doing discussion. Besides, we learned how to use the strengths and weaknesses among group members. Next, we managed to provide certain degree of planning and budget management. We also successfully implement the knowledge acquired theoretically onto hardware and proceed to enhance computer-aided design skills. This mini project enabled us to learn how to plan and manage our work, such as we must discuss what is the title and how it is operated before we start our work. When we discuss sync, we implement the theoretical knowledge that we learned in the class before into the design, and we successfully use Altera Quarters 2 to develop our final design and the output waveform. The knowledge that we implement in the design is final state machine FSM by using Mealy machine with 4D flip-flop in chapter 4 and by using shift register which is parallel in series out PISO in chapter 2. The result of this mini project meets our requirement, which is the fresh milk vending machine will only open when the money paid is fully RM3 ringgit. Thank you. In this mini project, we had designed a fresh milk vending machine using the skill that we learned in chapter 4, which is final state machine FSM. We decided to use Mealy model to design this vending machine and set the price of a tin of fresh milk for 3 ringgit Malaysia. The state diagram describes the behavior of the vending machine. We assume that RM0 is equal to 0001, RM1 equals to 0010, RM2 equals to 0100, RM3 equals to 1000. One of the behavior that we can observe through the state diagram is when the total of both inputs are 3 ringgit Malaysia, then only the customer will get a tin of fresh milk. The transition table and state table show the present state of the amount of money that customer had paid, the inputs which are D equals to IM2 and N equals to IM1. The next state is the additional of input and present states. The output will only be 1 when the present state is 3 ringgit Malaysia. After constructed the table, we construct the K-map to get the simplified Boolean expression. K-map is a visual method of simplifying Boolean expression in Boolean function without having to reuse complex theorem. After constructing the K-map, we have discovered 5 Boolean expression and we continue with designing the circuit diagram. To determine whether the circuit is correct or not, we have constructed it on quarters 2 and it can do compilation successfully. Then, we proceed with the waveform and we determine that the answer for the waveform is correct. The project is done successfully.